Welcome back, students. In this video, we're going to do Module 4, Topic 3. This is Part 1. It's split into two parts just so we have a little extra time and do a little extra practice. The standard for this half of the topic is, and actually it's the same for both, but anyway, GR 2.1, given a pre-image, an image, describe the transformation and represent the transformation algebraically using coordinates. We also have GR 2.3. Identify a sequence of transformations that will map a given figure onto itself or onto another congruent or similar figure. The objective for this topic, you guys are going to use rigid transformation to rotate figures on the coordinate plane and describe the effects of the rotations. So the warm-up here on page 10 of the Module 4 packet. Graph the line perpendicular to the line that intersects with point -4, 4. So we got a little bit to unpack here. All right, so let's think about this. So we've got this line here. Now they want us to graph a line perpendicular. So what is perpendicular to this line? It's gonna the slope of this line and the line we're creating, their product, going to equal -1. So let's just keep that in mind. All right, so this is going to intersect at -4, 4. I'm sorry, with point -4, 4. Excuse me. One second. Give me 1 second. Okay, sorry about that. A little technical difficulty. Okay, so we're going to pass through point -4, 4. So we'll go -4 and then 1, 2, 3, 4. Let's see. -4. Keep doing that. Well, just forget that. Anyway, so it's going to be perpendicular to this line. It's going to pass through this point. So how do we find this line? First thing we're going to do is we're going to find 2 points that this line passes through so we can get the slope, and then we can find out the slope of the perpendicular line, and then we have a point to plug in there to find the y-intercept so we can give the equation and graph the line. So let's look here. So this guy goes through this point right here. This is 0, 3. I'll try to write this here. Okay, and this also, see, it passes through. Let's see. Yeah, let's go here. -2. No, wait a minute. Yeah, -2, 1. That's not -2, 1. That's -2, 1's right here. So hang on. Again, I'm going to pause. Okay, sorry again. I had marked the wrong point and my math was all wrong, and sorry. So this also passes through -2, 1. All right, so first we're going to get the slope. Our slope formula, y sub 2 over y sub 1 divided by x sub 2 minus x sub 1. So we're going to make, let's see how we're going to do this. We're going to make these guys x1, y1, x2. So many difficulties tonight. y2. This is terrible. Okay, let's scoot this over again. Get the light a little better. Sorry, can't edit. Okay, so x1, y1, x2, y2. So we plug in. All right, so our y's are 3 minus 1. Okay, there we go. And our x's are 0 minus 2. So we end up with 2 over 2. Yeah, so 0 minus -2. So 2 over 2, slope is 1 for this line. So I'm just going to put this out here. Okay. Now, the line perpendicular to this, the products are going to equal -1. So what do you multiply times 1 to get -1? -1. So let's just put over here to the side. We're going to put this in y equals mx plus b form. Now we are going to, so our slope for this is going to be -1. So there's our slope. Now we need to, in order to find our y-intercept, we need to plug in x and y. We have an x and y right here for our line that they gave us. So our x is -4. Keep the b because that's what we're looking for. And y is 4. All right, so -4 times, -1 times -4 is +4 plus b. We got 4 over here. We got to subtract 4 from both sides to isolate b. Uh-oh, guess what? B is 0. So we know another point. Well, actually, we don't know that yet. So b is 0. So our y-intercept for this line is 0. So now let's put our, so we have y equals, our m was -1. So x plus b, well, our b was 0. So -1x plus 0, or y equals -x. So remember, we talked about in class in the previous lesson, the y equals x, that line goes this way. Well, that's actually going to be perpendicular to this line. So the one parallel, parallel to this line. So the one perpendicular is going to be y equals -x. It's going to go this way, but you have to apologize. Here's our -4 point. We also know it goes through y at 0. We go here. And that's as far as I'm going to go because I left my compass in the classroom. All right, so this hits this line perpendicular to this line. So let's give it a little box just so we're keeping with that, even though you guys can't see it the way this goes. So the line perpendicular to that, there it is, and this is the equation for it. All right, let's cruise on down here, bottom of page 10. This is a short lesson, like I said, but we're going to get extra practice from that, so that's good. All right, rotations about the origin. We talked briefly about rotations back in Module 2. We're going to get a little more in depth here. We're going to start with the 90-degree counterclockwise rotation about the origin. I can tell you that we will do clockwise, and I have a anchor chart that has the clockwise and counterclockwise broke down. I can tell you on the next page it's not going to say, but we assume counterclockwise when it doesn't say. Just spoiler alert to the next page. All right, so but for a 90-degree counterclockwise rotation, of course, counterclockwise, let me draw. It goes this way. And then if it was clockwise, it's, of course, the other way, the clock runs. So, 90-degree counterclockwise rotation. This is our example over here. I'm going to try to zoom in just a little. So here's our P. It's at 5,2. We're rotating over here 90 degrees. So see, it went this way, as I show you over here. Yeah, I just put it around. But to get this, to get our coordinate rule, the words multiply the y-coordinate by -1, and then interchange the x and y. So our x comma y becomes -y comma x. And I recommend write these down. Of course, we have our anchor chart in the classroom, but if you guys kind of make a habit of writing this, it'll somewhere in the back of your brain it's going to stick, especially come EOC time. That's my hope. So look what happened here. So when we rotated 90 degrees, P at 5, 2, the 2 went up front and became negative, so -2, and then the 5 went from the x went from the front to the back. So 5, 2 became -2, 5, just like it said. All right, 180 degree counterclockwise rotation about the origin. We multiply the x and the y both by -1. So your x comma y becomes -x comma -y. So our example over here again, P's at 5, 2. When we go 180 degrees this way, 5, 2 becomes -5, -2 to rotate it exactly 180 degrees. All right, for 270 degree counterclockwise rotation around the origin, we multiply the x coordinate by -1. Then you interchange the x and y. So just like we did up here, except we're making the x negative. Well, we are flipping them. So your x comma y becomes y comma -x. So P, when it rotated all the way around there, P 5, 2, we put the 2 up front, and then the x we put in the back, but we made it negative. So 5, 2 became 2 -5 to go that far. Let me just move here a second. This is a table. We saw it before. There is an anchor chart in the class for this one. So, and I know you guys are still struggling with this whole replacing letters with numbers, but this is your x, this is your y. Again, your direction, A, by your magnitude, B, up and down. So, up here, remember, to the right and up is positive. I mentioned that a couple of times. So your top right is going to be positive, positive. So when we go over here, 90 degrees, if we're going counterclockwise, we flip these and put the y becomes a negative, like it said above where you can see now. So it's -BA. We're just using these rules. It's just in AB instead of XY. If you guys want me to put it in XY, I can do that too. Now, going 180 degrees, you take AB or XY and you multiply them both by -1, like it says here. So AB becomes -A, B. And then likewise down here, when you're 270 degrees from where you started, the Y goes up front, or the B goes up front, and the X goes in the back, and it's negative. So AB or XY becomes B -A or Y -X. Hope that makes sense. All right, let's flip the page here. All right, top of page 11, number 1. This parallelogram FGHJ has vertices and gives us the coordinates for F, G, H, and J. It says, what are the coordinates of the vertices of its image? So that's the after. Remember, the pre-image is where we start. What are the vertices of the image after a rotation of 90 degrees about the origin? So, like I said from the previous page, your spoiler alert, we're going to say counterclockwise. So, what is the rule? You guys in class are bad about not flipping the page back. So, if you flip the page back, it's going to tell you that 90 degree counterclockwise, the x comma y is -y comma x. Okay? Always crowded. Okay. So, let's write our coordinates down here. So I gave us F is, let's get a second page over here. So F is at 2, 1. G is 7, 1. H is 6, -3. And J is 1, -3. All right, so there's no math. We're just flipping and putting the -1. We're putting the y up front and making it negative. We're multiplying it by -1, and then the x goes in the back. So no math. So f prime. So 2, 1 is going to become -1, 2. Okay. G prime. 7, 1 is going to become -1, 7. H prime, 6, -3. Multiply that by -1, that's going to become +3, and then x goes in the back. J, 1, -3, again by -1, that's going to become +3, and then 1 goes in the back. That's simple. All right, number 2. This is a you do. So please pause the video, try to work this problem. I'm going to wait 3 seconds before I continue. After you work it, see how you do. All right, number 2. Parallelogram, FGHJ, has vertices. It gives us the coordinates. What are the coordinates of the vertices after a rotation of 180 degrees about the origin? So again, counterclockwise, which 180 degrees doesn't matter, because if you go counterclockwise or clockwise, if you go 180 degrees from where you started, you're the same distance away, because of the 4 quadrants. Anyway, so 180 degrees. So our coordinate rules for this, x comma y, it's going to be -x comma -y. Okay, yes, I just double checked, in case you guys are wondering. So let's write our f is 2, 3, g is 8, 4, h is -6, -1, and j is 7, -5. So we're just multiplying them by -1. So if they're positive, they're going to become negative. If they're negative, they're going to become positive. So your f prime. So we have 2, 3. So it's -2, -3. G, 8, 4, -8, -4. H, -6, -1, +6, +1. J, 7, -5, -7, +5. I'll scoot over here. Number 3. How many degrees was figure A rotated around the origin to its image, figure B? So here's A, here's B. We have 4 quadrants. It doesn't say, but we're going to say counterclockwise, but this is halfway. It's 180 degrees, so it doesn't matter. If you go this way, so you say 90, 180, or you say 90, 180. So this is a 180 degree rotation. Make sense? All right, number 4. And we're going to, it's a you do, but I'm just going to go ahead and tell you we're going to go counterclockwise. And we go 1, and it's 90 degrees. I know that was a you do, but I'm not going to take the time to pause when it's something like this. Hopefully you got there before I told you. That's what my goal is, to get you guys to the point where you start kind of picking up on what I'm putting down early and start answering for me, instead of me talking to myself like I am right now. Anyway, guys, independent practice is the bottom of this page. I believe it goes to the next. I'm not sure. I had to reprint my pages tonight. Long story. If you have any questions, let me know in class. Until next time, have a good night.